Okay, so we're still in section 5.2. This is the third page of the notes. We're at example 2 at the top of the page. So we're given this graph. This is all considered to be one graph. So for the vertex set, remember we do this in set notation, which is our curly braces, and we just list the letters A, B, C, D, X, Y, and Z. For the edge list, we want to list all of the edges we see in the graph. So if we just go alphabetically, if we start at A, notice there's two different edges that go to X, so we do have to list those twice. So AX, AX, and A also goes to Y. Moving over to B, we have B to X and B to Y. Okay, now if we move down here to the bottom, I'm not going alphabetical, but I'll finish this part. We've already listed these two, and we've listed X going to B, so we just need X to Y. Sorry, this one's a Y. Bad handwriting. And it looks like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We've got all those edges. C isn't connected to anything, so our only other edge is going to be D, Z. Alright, so if we do the degree of each vertex, remember for this we count the number of lines coming off of that letter. For A it's 1, 2, 3. And then we move on to B. For B we see 2 lines, so 1, 2. If we do go alphabetically and jump over to C, notice C doesn't have any lines coming off of it, so its degree is 0. The degree of D, we only see 1 line, so it's 1. The degree of X is going to be 1, 2, 3, 4. The degree of Y is going to be 1, 2, 3. And then the degree of Z just has 1 line coming off of it, so that's 1. Now for number of components, this is what we call a disconnected graph. So it's the number of pieces this is cut into. So here's one piece here that contains these 4 letters. C is all by itself. That is also a component. And then DZ is a component. So this graph is split up into 3 parts or 3 components. Now for our last example, we're supposed to do this without drawing a picture. You can go back and draw the picture if that helps. You just list your vertices out. I tend to do them in a circle, and then you can draw your edges. But I'm going to show you how to do this without using the graph. So the first thing we're asked to do is find all vertices adjacent to D. So what I do here is I find D's in the edge list. So anywhere we see a D, there's one here, here, and here, then whatever letter is attached to that, there has to be an edge between them, and that makes it an adjacent vertice. So we'll list A, we'll list B. Now notice D, D, that's a loop, so we're going to list D, and then I missed one. We also see a D here, so E is adjacent. Alright, so part B, we're asked to list all the edges adjacent to BD. So here what we do is we look for any edges with a B or a D. Now we don't want to include the one given to us in the list, so we're going to take that one out. But as we go through the list, if it has a B or a D in it, we're going to write it down. So we're going to write down AD. Not AE. BC has a B in it, so we'll write that down. Okay, then this is the one we're talking about. This is the one we're starting with, so we don't want to list it. DD has a D in it, so we list that. And DE has a D in it, so we list that. To find the degree of D, we're going to count the D's in the edge list. Okay, so I'm going to go through and mark these. There's a D, there's a D, there's a D, there's a D, and there's a D. So if I count that, that's going to be 1, 2, 3, 4, 5. So the degree of D is 5. Now the last one is the trickiest. It says find the sum of the degrees. So to do this, we have to find all the individual ones. We already know D, so let's do the degree of A. So we're going to go through and just count our A's. I see 1, 2, and that's it, so that'll be 2. The degree of B, I go through my edge list and I count my B's, so that's going to be 1, 2 again. For the degree of C, only see the letter C once, and that's right there, so its degree is 1. We already found the degree of D, we know it's 5. And the only thing left in our vertex set is E. So if we go through and count the E's, that's going to be 1, 2. Then to get our sum, we're just going to add all of those together. And that gives us a sum of 12. So that is the sum of the degrees of all the vertices.